Hello everyone. Today I will be discussing the steps and approaches I took to build a model to predict the electrical energy output of a combined cycle power plant using environmental sensor data which we have from the portal. So in this demonstration I will cover the modeling approach, model building, model evaluation and model interpretation, and I'll also highlight the methods and also the results which I obtained. So the modeling approach. So to start, based on the instruction, I used Excel, so I correctly identified that the type of modeling task at hand was a regression problem. This is because our goal was to predict continuous numerical value, specifically the net hourly electrical energy output of the power plant. So for the features, I chose to use the following variables which were provided in the dataset: temperature, exhaust vacuum, ambient pressure, relative humidity. So these features are crucial as they directly impact the power output. And so for this project, I chose to use linear regression due to its simplicity and interpretability. So model building. So in the model building phase, I used linear regression as my model. Here is how I split the data. So I divided the data set of 9568 rows into five different sets. So the first four sets will have 2000 rows each, and the last set would have 1568 rows. And then I used each set as a test data while the remaining set served as a training data. So in that way, I was able to create five different models for the different set of data for five folds of data. And for all the five folds of data, I calculated using data analysis. I did a linear regression, and then I used the linear regression equation using these coefficients. So basically, temperature coefficient into temperature value, so on, and created that equation to predict the outcome of the test data. And after that, I calculated the root mean square of the predicted and actual data of all the test data. So in that way, for five different folds, I got five different root mean square values. So for the first fold, I got it as 4.58. For the second fold, it is 4.72. For the third fold, it is 4.63. For the fourth fold, it is 4.38, and for the fifth, it is 4.47. So considering all these values, the root mean squared error as a primary metric was because it provides a clear measure of how much the predicted values deviate from the actual values and in the same units as a target variable. And after training the linear regression model and after evaluating all these five folds, um, the range of the RMSE values is from 4.38 to 4.72. So this shows that model has consistent performance across different sets of data. And finally, I interpreted the performance of linear regression model, and the consistent RMSE values indicate that uh, this model has performed correctly. And although it's a simple model, it provided a good baseline for this task. And I also analyzed, as I said, coefficients of linear regression model to understand the impact of each feature on the power output. So temperature and exhaust vacuum were among the most significant predictors, and which aligns with our understanding of their physical influence on power generation. So in conclusion, by correctly identify type of modeling task and selecting relevant features, using linear regression, setting an appropriate evaluation metric, and effectively interpreting the model's performance, I was able to build a predictive model for this power plant's energy output. And that's the linear regression model with its RMSE values ranging from 4.38 to 4.72, demonstrated its ability to accurately predict the power plant's output based on environmental conditions. Thank you for watching, and I hope you found this overview of my mini project insightful. Thanks everyone.